Welcome to the new section of this course, titled Securing the Web Application. In this section, we will look at topics such as the Web Application Stack, security threats in application logic. Now let's move on to the video, the Web Application Stack. In this video, we will see security alternatives in the platform and learn two OSI layers, Transport Layer and Application Layer. Let's start with network security versus application security. In today's scenario, web application security depends upon two primary surfaces, the web application itself and the platform on which it is deployed. You can separate these two surfaces as any web application cannot be deployed with a platform. It is very important to understand the distinction between a platform and an application because of the impact it has on security. A typical web application would have an architecture similar to the one depicted in this diagram. Most web applications depend on web server, such as Apache or HTTP server, Rails, Nginx, and others, which actually handle the incoming request based on the type of application. These web server keep track of the incoming traffic. They also validate the request and respond to it accordingly, considering all user authentication is validated. In our case, Flask acts as the web server for our application. Let's see application security alternatives in the platform. As seen earlier, every web application needs to be deployed on some kind of a platform before it can be exposed to the outside world. An application platform provides the protocol support application, which is needed to communicate over a network. TCP, and to a larger extent, HTTP, are all handled at the application level. In the network stack of software architecture, there are two distinct layers, which include protocols ripe for web application attacks. In the application platform, these layers are as follows: transport, application. Let's see these layers in detail. Let's see transport protocol. In the Open Systems Interconnection model, that is OSI model, the transport layers is commonly referred to as Layer 4. Web applications use TCP protocols as their transport protocol because of their reliability. In TCP, that is Transport Control Protocol, each packet is closely monitored, and error recovery mechanisms are inbuilt, which is very useful in case of a communication failure. These mechanisms are exploited to attack web applications. The most common attack is the SYN flood attack, which is a TCP request for acknowledgement attack. The SYN flood attack severely affects the application by using an idle session to establish a connection with the application server and keeps on requesting until the server runs out of resources and is no longer able to handle more requests. In order to avoid such kind of attacks, system administrators should set up a configuration related to timeout and idle behaviors after considering the impact on the customers. Another example of such kinds of attacks is the Smurf attack. You can refer to this link for more details. Next is secure transport protocols. In the OSI network model, we also have some protocols on Layer 5, which can make your network more secure and reliable, SSL or TLS. However, this layer also has some vulnerabilities. For example, Heartbleed 2014 in SSL and Man-in-the-Middle renegotiation attack 2009 in TLS. Now we will look at application protocol. In Layer 7, that is the topmost layer of the OSI network model, the actual application resides in and uses the HTTP protocol for communication, which is where most of the application attacks occur. HTTP, that is Hypertext Transfer Protocol, has mainly these two components. One is metadata. HTTP headers contain the metadata, which is important for both the application as well as the platform. Some examples of headers are cookies, content type, status, connection, and so on, and behavior. This defines the behavior between the client and the server. There is a well-defined flow of how messages should be exchanged between a HTTP client, such as a browser and the server. The main problem here is that an application generally doesn't have an inbuilt capability to identify suspicious behavior. For example, a client accesses the web application over a network, which may be attacked by consumption-based denial of service, that is, DOS attacks. In this attack, the client purposefully receives the data at a slower rate than the normal indicate which they are capable of, in an attempt to maintain an open connection longer. Due to this, the web server's queue starts filling and consumes more resources. If all the resources are used up with sufficient open connections, it is highly possible that the server may get unresponsive. A word on developing security-enabled web applications. With an increase in web applications on the World Wide Web, that is WWW, the concerns over application security have increased as well. Now, the first question that arises in our mind is why we need security-enabled application. The answer to this is quite obvious, but what are its essential principles? Here are the principles that we should keep in mind. A hacker can easily exploit your application if he gets familiar with the language in which the application got created. That's why we enable techniques such as CORS to secure our code. Access to the application and its data should be given to very limited people in your organization. A way of authorization secures your application from both the www as well as within your private network. All these factors, or as I would say, principles, drive us to create security-enabled applications. So here we have come to the end of this video.